Wow, so that works. Good afternoon, everyone. My name is Adeola Additional, like you always know. I'm co-founder of Young Pharmacists in AI Africa. And once again, like we always do, we've come to another mentorship session with one of the foremost. Oh, sorry, let me mute this. So we've come to another session with one of the foremost AI experts in Africa, who is based in South Africa, actually. He's been supportive of the Nigerian AI ecosystem since Data Science Nigeria started in the past 2 years. Dr. Ludik is one of the AI experts in Africa that we look up to. Dr. Ludik, I want to say thank you for finding time to allow us grow, finding time to allow us get better at what we do. Thank you for all of the time that you give into mentorship for young Africans. So without without further ado, I'll just need to say a few words before we go into the session for today. So Dr. Ludik, over to you.
Thanks, Adeola. Thank you very much for the opportunity to present here, and welcome everyone. I think you mentioned there's a number of people across Africa and also here from South Africa. I'm speaking here from Cape Town, South Africa. And what I will do is to quickly switch over to my screen so you can actually see the presentation. And what we also intend to do is to actually share the presentation afterwards. I'm actually planning to do 2 presentations, and we can have a Q&A maybe after each one or maybe after both presentations. So looking forward to your engagement, and thanks for the opportunity. So what I will do without further ado, Adeola, is that if that's all right with you, can I start?
Yeah, you can start. And anyone that has a question can do ask your questions on the live chat and the YouTube channel so we can catch you and then answer all the questions that you have.
I'll have a look. So thank you very much. Okay, good stuff. So let me switch over and quickly share my screen. Okay, so just hide that. Adeola, can you see my screen?
Yes, I can.
Okay.
Yes, I can.
And you can hear me clearly?
Clearly, very clear.
Okay, fantastic. Okay, so I'm planning to do 2 presentations. The first part of it is really focused on AI-driven digital transformation in the smart technology era. So that's the first part. And the second part will focus more on pharmaceutical, biomedical engineering applications, and maybe talking a little bit more about AI machine learning as well, giving a little bit of an intro. I know that the audience is not necessarily experts in artificial intelligence or machine learning, but so I'll keep it high level. And if there's specific questions after that, we can surely talk about that. I do have a third presentation that just talks about data science skills. I know there's a number of people amongst all these pharmacists that actually want to up their data science skills. So I'll be talking a little bit about that as well, or I can at least go back there if there's any specific questions. So I'm going to start without further ado. Let me just put this into full screen mode. So what I would like to do, just before I talk about digital transformation, I talk about smart technology era, just a little bit of background. So my company is called Cortex Logic, and we are an AI engine for business. And specifically, our aim is to help businesses thrive in the 4th Industrial Revolution or the smart technology era. And when we talk about operationalizing data science and artificial intelligence, this is in fact what we do. So it's a great opportunity for me just to speak about this particular topic, because this is in fact the focus of the company as well, is to really operationalize data, unstructured data, structured data, operationalize AI, providing end-to-end solutions. And I just want to talk to what that means, also for organizations, for enterprises, and so forth. So just to set the scene. So this is just, maybe just quickly, this diagram is also testimony to that focus when we say we do kind of three big things in operationalizing AI. The first step is to really enable smart data for automated AI. And what do we mean by that? That means that you need to have the data foundation sorted out. You need to know, you need to be able to access all available structured and unstructured data. If it's in the medical or pharmaceutical world, that means all the different types of, for instance, you can look at MRI scans, you can look at electronic health records, and the more data you've got of a particular patient, for instance, the more you're actually able to do. It opens up a lot more use cases and potential business value outcomes as well. So it's very, very important to have the foundational data layer sorted out. The next step after that is to obviously apply data science, AI, machine learning. And what you effectively want to do is, in the end state, is to automate that as well. So, and you can't automate AI if you don't have access or rapid access to all available data. And then from there, you need to integrate that into the business. And what that means is that you need to take the application or the model that you've developed, say it's a churn prediction model, and then you want to make sure that you can actually deploy that model in a business to actually be impactful. And ways to implement things, another example is, for instance, intelligent virtual assistants, is where you actually build models that predict what people are likely to be interested in, or you can make some recommendations, but now you can interact with that person. Another example is where you've got machine learning, for instance, reading emails and doing auto replies or putting emails into buckets. And the moment you actually do something, you act on the data, on the insights, you're starting to integrate that into the business. And that's in fact what we mean by that. And if you think about use cases just from a pure business perspective, there's many, many different ways you can actually help a business thrive. And it could be very specific around pieces of equipment or processes, or it could be the whole business, where you're actually driving the revenue, the growth, the driving costs down, reducing risk, and doing all those type of things. And then for all customer-facing businesses, you want a growing customer base. So what do? You want to reduce your churn. You want to increase your upselling and cross-selling, all of those type of things. If you think about your business, you also want to empower your employees to be more productive. So you want to make sure that you actually enable them with AI technology to make them more effective. So there's a bunch of things that we can do on that front. And even if you think about human resources, I've done many, many presentations on all the different types of applications of artificial intelligence in HR. So that's another one. And then finally, if you look at the smart systems bucket, it's really focused on anything like fraud detection or cybersecurity, or if you think about process performance enhancement, if you think about IoT type of solutions, IoT provides you with more data, more information, so that provides another opportunity to unlock value. Then I always like to start with a value driver. So when we talk about operationalized data science, operationalized AI, building AI-driven solutions, you need to think about what's really important to the business. You need to think about what are the business key performance indicators. And what I've summarized here is really value drivers for business across multiple industries. So if we just focus our attention on the left bucket here, what you see here is really a focus on increasing operational efficiency and effectiveness and revenue. So you can apply artificial intelligence, data science, doing digital transformation to actually increase your productivity, increase your revenue, reduce your risk, or lower your costs. So how do you increase your productivity? So one way would be to increase your automation. If you've got things more automated, I've mentioned that emails, for instance, if you've got a way to actually not manually deal with emails, but you've got machine learning, reading emails, putting things into buckets, making it easier for people to act on the real problematic emails or where it needs more attention. That is a way of automating. If you think about any manufacturing or mining process, then anything like improving the processes or equipment availability means a higher productivity. If you think about increasing revenue, again, if you think about the industrial world, the manufacturing world, increasing throughput, yield, and quality is a major driver of revenue if you get that right. And again, you can use artificial intelligence and data science applications to get that right. If you think about consumer-facing businesses, you obviously want to increase your number of customers. You want to make sure they're happy. You want to be relevant for them. So cross-selling and upselling recommendations are all very important. But then if you think about risk, many things is important here. You want to make sure that you don't have equipment failure. You don't want customers to churn. You don't want fraud, waste, and abuse. And if you think about even the healthcare sector, we actually see quite a bit of fraud, waste, and abuse by many of the stakeholders there. So you can implement systems that's actually identifying fraud, identifying waste, identifying abuse. Another big one, because the world is really becoming more data-driven, is cybersecurity. Especially with the digital transformation, one needs to look at ways to actually protect the business. And cybersecurity and AI applications, cybersecurity is of major importance. And if you think about lowering costs, then here again, you can build business cases to, say, eliminate redundancy. Or if you think about energy and raw material usage, how can you actually optimize that, your operations and maintenance? So these are all examples of value drivers for business that's absolutely key. So if you think about the topic of this talk, really we talked about data-driven, or how do we unlock value from structured to unstructured data. So data is really going on an exponential curve, is being generated on an exponential curve. And data usage is really linear compared to that. So that gap is constantly increasing. So there's plenty of opportunities to think about these value drivers and how can we actually utilize the available data to start addressing these problems. So this is one big bucket. Another big one is, and we see this with all these new platform businesses. If you think about Uber, Airbnb, and all these businesses, and Google and Facebook, etc., they are monetizing their data. So you can actually create data, generate data, and create strategic value based on the data that's available to the business. You can also enrich your own data, the company's data, with other types of data, and that could open up more opportunities. Another way to think about this is if your company has got a certain, say for instance, you've got healthcare data, and you can start partnering with a company that's got insurance data. Just that combination opens up interesting opportunities and doors. So there's clear opportunities to have new business models, and there's new revenue growth opportunities that can be tapped in. There's opportunities for smarter R&D, innovation, all sorts of things. And obviously, it also helps with decision making. I think that's what you want to make sure. I think in the smart technology era, it's really about how you can be agile and how you can be faster, better, and more proactive with your decision making. So it's about acceleration. So that is absolutely a key factor. And then the last bucket that I've emphasized here is really, if you think about customer-facing businesses, and it's also relevant for pharmaceutical industry, healthcare industry. You want to make sure you provide the best possible give the best possible customer experience to everyone involved in the healthcare sector. But what do people want? And this is what you actually see with the world, digital transformation in the world that's happening around apps and people and use of cell phones and smartphones, is that people are expecting real-time, on-demand, digital, personalized service delivery, assistance, and advice. It's almost like expected. And so that means there's pressure on businesses to actually provide that service. So this again is where intelligent virtual assistants and advisors robo-advisors and those type of applications can come in. But again, that needs to be fed by really a proper 360-degree view or insights about the customer in terms of what they want, predicting their specific needs, because you want to be relevant in your communications. So the relevancy is a very, very important thing. And then there's a number of other use cases around that as well. You could be obviously more targeted in terms of your sales and marketing and so forth. So this is just explaining a little bit of the value drivers. I'll go into some of the technical details as well around these things. This is just an example. I'm not going to go into what the company specifically does, but this is just to give you an idea of the types of solutions that's available within each of these buckets to actually enable value. So I'm going to stop there with that. The other piece of background that I want to give is just, so the Machine Intelligence Institute Africa is also AI data science community. That the real focus here is transforming Africa through data science, research and applications. And so I really encourage you to, I know you're part of the young pharmacists in AI, which is fantastic. And what we want to do from a MIIA side, MIIA is a non-profit organization, we want to actually help with the mentoring support of all AI activities and AI data science activities across the continent. So help other organizations as well. So this is a perfect opportunity as well. So thank you for that. Just a little bit of background there. You can see some of the partners. You can go to machineintelligenceafrica.org to get a bit more information. And you will also see the events, activities, and growth path, also as indicated on the events page. So just a little bit of background there. So what I would like to do now is to just go to and focus on the fourth industrial revolution, the smart technology era, because I've referenced that and I said this is, I talked about this. So let's just give a little bit of information about the smart technology era. And then I'll talk about artificial intelligence within the smart technology era, what it means, what's the impact, and then we can go into more details about unlocking value. So my personal massive transformative purpose with business and MIIA and Cortex Logic and things that I've just explained there is really how can we shape a better future in the smart technology era. And if you think about specifically, it seems like most of the audience are in the healthcare space. So there's so much opportunity to help shape a better future in healthcare, specifically if you think about Africa. And what I would love to see is that we actually utilize artificial intelligence, data science in the best possible way. So it's for me, I'm so excited to see the interest of, say, pharmacists, people with domain expertise in healthcare and pharmacy and biomedical engineering, and their eagerness to actually want to know more about AI and data science. And I think it's absolutely fundamental building block to help shape a better future. So I would really encourage people to continue on this journey to try and understand how you can utilize it. I'm going to show some examples later on, especially in the second part of this talk. So absolutely very excited. So the fourth industrial revolution is I just call it the smart technology era because I don't think it's just industrial. It's really affecting all economies, all disciplines, and across many sectors. So a little definition here is what is the smart technology era? What is the fourth industrial revolution? So it really builds on the digital revolution that all of us are very aware of. And it is characterized by a fusion of new, very interesting exponential technologies that's really blurring the lines between the physical, digital, and biological worlds. And artificial intelligence is clearly one, but there's biotech, there's nanotech, there's quantum computing, there's blockchain, there's all of these type of technologies that's also coming into play and very key building blocks to help unlock value and shape a better future. So this particular slide is just giving a little bit of history, and I would also, if you think about history and seeing things in perspective, there's actually a good book that I would recommend called Sapiens that actually talks about the cognitive revolution and agricultural revolution and scientific revolution, and within the scientific revolution, you've got the 4 industrial revolutions. And that's a great book to give you some perspective of Homo sapiens and the journey that we've been on. Now, if you think about just focusing on the scientific revolution, and specifically in the industrial revolutions, we can see a little history the last, say, 150 years, where you see the first industrial revolution really focused on using water and steam power to mechanize production. The second one was really using electric power to create mass production. The third one in 1969 with electronics and IT and automated production was really focused on using electronics and information technology to automate production. And then the fourth industrial revolution, this is one that builds on the third, the digital revolution. And the way of kind of summarizing it, I'm saying it's creating smart automation. It's not just automating production, it's actually creating smart automation. This smart automation is where things like artificial intelligence comes in, and making a major impact. So you see this kind of cyber physical systems kind of era. Now, just a few quotes from, I think this is from one of the previous World Economic Forum meetings, where some of the speakers were just quoting specific things around the fourth industrial revolution. And here, for instance, you can see Robert Schiller, which is saying we cannot wait until there's massive dislocations in our society to prepare for the fourth industrial revolution. And Paul Kagame here was saying the opportunity to raise the quality of life is the biggest business opportunity. John Chambers from Cisco was saying if you don't move fast, disrupt your industry, disrupt yourself, you'll be left behind. And MIIA was saying the fourth industrial revolution should be a revolution of value. So all these people are focusing on very important things. Obviously, you can see the urgency. We don't want to be left behind. We talk about massive dislocations. This is of very big importance for especially Africa. Where are we going? So we need leaders. We need people that's empowered with smart technology so that we can leapfrog. We need that kind of leapfrogging to happen. We obviously need the infrastructure. But if you look at the bottom here, the focus is really on quality of life, the revolution of value. So I think very important to also keep that in mind. What does it mean for us to be human in the smart technology era? And I think we've got opportunity to help shape this future. And Klaus Schwab, the president of the World Economic Forum, was saying it's not in the new world. It's not the big fish which eats the small fish. It's the fast fish which eats the slow fish. So again, the emphasis on being agile, fast, making sure that you've got the right tools to actually implement these kind of solutions. Now, this last slide on the smart technology era is just emphasizing also the exponential nature of the smart technology era, and specifically these exponential technologies. We actually call them exponential technologies. And you can see biotech, neurotech, nanotech, artificial intelligence, all of these. And there's a lot more that you can add to this list. But I think what we are seeing is actually the combination of these technologies creating all sorts of very interesting applications that could be game-breaking and breakthroughs and solve problems. So that's the opportunity. And it's tremendously exciting. So I think we live in a very, very exciting world. If you've got people that know how to work with data, unlock value, know how to use these exponential technologies, we can help shape that better future. But it's very, very important to obviously think about positive outcomes, think about ethical outcomes, and apply these kind of technologies in the right way. Okay, so that was that. So let's just focus our attention now, just shift gears a little bit, and think about businesses. And I know some of you have got pharmacies and operating in the healthcare industry. So what does this mean for you and for businesses in general? So we need to think about AI-driven digital transformation in the smart technology era. So on this particular slide, I'm just summarizing the 5 elements of successful AI transformations. So it always starts, and I think it's important, with the intent, the strategy. What is the use cases? What is the sources of value? And that is exactly what I showed in one of those first slides, where we talked about the business value drivers. it's very, very important to have that sorted out. So what I do also with lots of businesses is we actually have these kind of AI workshops where we sit with the executive team and we identify those sources of value. And we talk through what could be quick wins for that particular business. The next very important pillar is data. So you've got to make sure that you've got your data ecosystems is sorted out. So you want to make sure you've got access to all available structured and unstructured data. And so I'll talk later on a bit more about that aspect as well. The third pillar is technology. So this is where artificial intelligence and frameworks and all sorts of things that relate to smart technology comes into play. The fourth one is process, which is really focusing on how do you actually deploy these kind of systems, and what is it? How do you integrate this into workflows, into processes? And then people, very, very important. So if we do implement AI solutions, then it means that jobs or the nature of jobs are changing, and the roles are changing. So people need to we need to think about how their roles should be adapted pre and post this whole transformation as well. And I think also very important is this whole thing around open culture and organization. So on the bottom here, right bottom, I also have again the 5 pillars: data, technology, people, intent, and processes. But what I'm showing here is you can see on the x-axis we've got time. So if you want to accelerate, if we talk about acceleration, or accelerating the path to value generation, then you actually need to bring that curve back of data value generation. And how do you do that? You actually do this by taking all 5 components into consideration. So, and here you can see, for instance, if you want to start actually moving that curve back, data availability is important. Now, if you've got lots of different data, you need to think about your computing. You maybe need to do in-memory processing. Do things in Spark, for instance, or have distributed computing, doing the computing on your data. So distributed computing is important. Then think about your AI analytic tools and platforms. What is the best platform? So I'll later on talk a little bit more about that. Then if you think about people, there's many, many things that you need to consider in this case. But if you think about just the people that you need to actually unlock the value, you need data science skills availability. If you don't have it in-house, you typically partner. And this is, for example, what Cortex Logic is doing. We are an AI solutions provider, and we help to unlock value for companies. So as an AI partner, we're creating an AI engine for business. So that's an example. But those kind of skills are very important. Also, how do you integrate that? How do you train these kind of systems? So all of that is very important. And then the intent, organizational alignment, and process and change management, very important. So all these are important factors to actually unlock value. And if this is, again, talking to exactly those 5 components that I've just mentioned. And here I'm just going into a little bit more detail. I'm not going to take too much time on this now, but you can see, again, sources of value, articulate the business needs and create business value. If you look at the data systems, you can see some very specific things. And what we find with businesses, they typically have data silos. You've got to break down those data silos. Very, very important, because we just talked about rapid access to all available data. You also need to decide on the level of aggregation and pre-analysis and identifying high-value data. Not all data is of high value. So how do you actually get to those high-value data? And then the same with technology. You need to think about identifying fit-for-purpose AI tools. You want to partner or acquire to plug capability gaps. You want to be agile. You want to really focus on quick wins, test and learn type of approaches. And then if you think about the process, things like integrating AI into the workflow processes, optimizing the human-machine interface, very, very important. And then on the people side, you want to adopt an open, collaborative culture. You want to build trust. You want to reskill the workforce. So those are very, very key things that one needs to do. And then you can measure this. You can say, okay, let's look at intent, process, data, people, technology. And if we measure it, we say, oh, maybe we're just in an ad hoc state or opportunistic state around that. But then the digital transformation journey is to really take you to an optimized state in terms of intent, technology, people, data, processes. So here you see some of the characteristics or the stage descriptions of what it means to be in an ad hoc state versus a repeatable state or optimized state. So, and there's a lot more detail for each of the 5 pillars as well: intent, technology, people, and data. And maybe later on, if there's questions, I can point you to a lot more material. But I would recommend the Industrial Data Corporation. That's an organization that provides really good frameworks around these type of things as well. And this is also maybe useful. I'm not going to go in too much detail, but I just want to make you aware of that. If you think about realizing business value, there is frameworks available for identifying AI opportunities. And in this particular framework here is really on the x-axis, we're talking about work complexity, and in the y-axis, we talk about data complexity. So if you think about opportunities where you can actually unlock value, if you think about work complexity, you would see routine, predictable, rules-based opportunities, and it moves all the way to ad hoc, unpredictable, judgment-based. And when it's in this quadrant, where you've got structured data, stable, low-volume data, and if you think about the work is routine, predictable, and rules-based, what you would find is that you can actually implement all sorts of different types of AI applications. And here's an example of automated credit decisions, package delivery via drones, etc. But typically, things are well understood. You can implement rules and all sorts of different things. And you can actually, we talk about an efficiency model. But when you move up here to more unstructured, volatile, and high volume data, more, say, real-time data as well, you can go into more of an effectiveness model. And what you see typically here is virtual agents or virtual intelligent assistants or advisors for consumers, for enterprise, customer service, collaboration, or workflow management. And when you move to the right-hand side, you see some potential AI applications addressing things like enabling creativity and ideation. And you see things like support for biomedical research, fashion design, music writing. If you think about the expert model, it's things like expert system for medical diagnosis, legal or financial research. Those are all examples of that. And there's in all of these, there are interesting AI opportunities as well. So another way of looking at it, on this side, it's more automate things. On that side, it's more augmenting. So on the right-hand side is more augmenting humans in terms of innovation and expertise. And the left-hand side is more helping to automate things and being more efficient and effective. Nice framework. Okay, so let's get to artificial intelligence. Just a few quotes. Artificial intelligence revolution this year. This is Salesforce. Mark Benioff says it will change your life. Andrew Ng was saying AI is a new electricity. Google CEO is saying we will move from mobile first to AI first world. So you can see serious emphasis on artificial intelligence. So if you think about artificial intelligence, so what is it? I'm going to just do a little bit of this, and then I'll shift to more of the machine learning and biomedical applications as well. So, Adiolis, everybody still fine? Happy? Okay, no answer there, so I assume everything is still fine. People probably on mute. So just to further continue, artificial intelligence is, I just want to quickly, just quickly go here, just on a sec. Okay. Okay, so let's continue. Just putting again in full screen mode. So, artificial intelligence really started in the 1950s, and really AI, if you think about it very broadly, it's really a discipline that focuses on developing machines and software with intelligence. That's a very simple definition, but that's in fact what it is. A subset of that is called machine learning, and it really started to flourish in the 1980s and it's really systems that can learn from data. This is what it's focused on. And a lot of the breakthroughs and the excitement around artificial intelligence and machine learning was actually can be attributed to deep learning. So deep learning breakthroughs really was responsible for the AI, driving the AI boom. And if you think about deep learning is really a subset of machine learning, and it's more focused on creating those high-level abstractions by creating these layers of abstractions, and it's composed of multiple nonlinear transformations. And I will just show some examples of that as well. Now, if you think about AI and machine intelligence landscape, and we just talked about the impact on all sorts of industries, here you can see this was a machine intelligence or AI landscape that was created by Bloomberg Beta in 2015. And since then, there was one created in 2016 and 17. I think there's 3 versions. And it was just showing some of the companies involved in some of the core technologies, trying to improve that. But I think the point of this particular slide is really what's happening here is one needs to rethink enterprise. One needs to rethink industries. One needs to rethink the human-computer interface. And if you look at it from an enterprise perspective, you can see that all the different aspects of an enterprise are really being impacted here. Sales, security, fraud, HR, marketing. And you've got even companies really focused on very specific solutions in these parts of enterprise. But you see the same thing with industries. And if you think about ad tech or agriculture education, for instance, diagnostics, you see, especially in the healthcare sector, there's a few companies, many companies focus on that particular sector. But you see these kind of impactful impact across industries and enterprise. Now, what's really happening here, and we are on an interesting journey where we've got choices that we need to make. Now, this particular slide is the sources from PwC. On the x-axis, we've got time. On the y-axis, we've got the size of the market. And this is actually showing the various ways you can, what we will see in terms of the man-machine intelligence continuum. So first of all, I think what we will see is the application of AI to assist us. So we talk about assisted intelligence. Then the move to augmented intelligence, and remember that tasks are automated. You see humans don't learn, but you see machines learn. And examples are machinery or process in factories, etc. But then on the augmented intelligence side, you see the nature of the task actually changes. And you see humans informing machines and machines informing humans. And examples of that is, for instance, business strategy analysis using AI or machine learning, or smart clinical decision support. And then when we move to autonomous, it's really self-driving cars, autonomous vehicles, smart investments, where you actually have machines that learn continuously. You've got decisions are automated, and obviously the nature of the task changes as well with that. So we are clearly on this journey. So the point is, what does this mean for us as humans? What does it mean for you as a pharmacist or a data scientist? So this is a slide that I've created based on some inputs and material that I saw from Dr. Kai-Fu Lee. He got a book out also talking about AI superpowers. And I've just augmented or annotated this particular slide. So in fact, what we are seeing here is that jobs going forward, you can actually, if you look at the x-axis here, you can actually put jobs into different buckets. You can say there's a bunch of jobs that's more repetitive, or at least it's got a range of repetitive tasks. You also see jobs that's more routine, or it's got more routine tasks. Then you can move to optimizing, more complex or creative. So this is kind of the spectrum, going all the way from where you can optimize to creativity and strategy. Now, if you think about, okay, so it's before I go to the various quadrants, let's just go to the y-axis. So what Dr. Kai-Fu Lee is advocating, and what I'm also supporting, is a world where we actually make sure that we're trying to make sure that there's a focus on being human-centric. There's a focus on compassion. And the moment you create that, you actually create jobs in the job market that you value, where you actually value compassion, for instance. And then when you do that, you can look at a y-axis here, where you can see this number of jobs where compassion is not really needed. But then you can go across the spectrum, up this y-axis, and you can get to jobs that's becoming more and more human-centered and compassion needed. So the moment you do that, now you create 4 quadrants here. And what you have on the left bottom one here is where you've got routine jobs and compassion not needed. So what you will find going forward in the next 5, 10, 15 years is that you will find AI pretty much taking over these kind of jobs. And the moment you move to the right-hand side, where there's more complexity and creativity and stuff, you will see AI obviously coming into this side, but you will also see human plus AI. Because obviously there is AI applications that will help with complex tasks, with creative tasks. We already see interesting creative tasks, but there's a huge play for us as humans on that front, and that we need to explore a lot more. I think in most of the jobs, we're almost kind of neglecting the creative part of things. Almost when we are small children and kids, we are more creative. And I think it will become important to actually start emphasizing that. And when we move above this line to more the compassion part of it, what we will find on the left-hand side, for all those particular jobs or tasks, and even the new ones that we create, where we say compassion is important and services is important, servicing the elderly, making, for instance, teaching, working with machines and AI as well, but say the teaching, make it more, make sure that we value that more. We can get to a situation where we've got the warm embrace of humans utilizing AI in providing all sorts of solutions. And when you move to the right-hand side, where it's more compassion, human-centric, and creativity and strategy, you will find more human and AI comes into play as well. So this is just a way of looking at the future job market and how we can potentially use AI in the right way, and where we should start focusing, and maybe also give some guidance in terms of creating that job market that we want. And if you think about healthcare and pharmacy, I think exactly the same. Think about how we can actually start creating these kind of things. So I think it's important that governments and businesses think about this type of framework in going forward. Now, if you think about the AI Toolbox, this is a slide that I also many times referred to, and it's kind of just showing the different things that you can do with AI and analytics to unlock value. So, and all of them are pretty important. I know on the y-axis I'm talking about increasing value here, but really you can unlock value with a combination of these analytics techniques and this type of technology. So descriptive is really addressing things like what happens. Describe historical data helps understand how things are going. When you go to diagnostic, it helps understand the unique drivers, segmentation, doing statistical sensitivity analysis, and it's addressing questions like, why did it happen? So it's actually really coming into hindsight, giving you some insight. Then I've added in here discovery, because you can also apply unsupervised data to look at the underlying patterns in the data and start visualizing that, detecting clusters in the data, what's the natural groupings in the data. And then you can move to predictive, where you can get really good value, where you start forecasting future performance, events, results, and basically addressing the question, what could happen? If you think about a customer, for instance, given the previous history, the previous behavior, given the segment, their interest, there are all sorts of aspects around the particular person, you can start predicting things as well. So, and in that way, you can be more relevant and more proactive in what you want to do. So this is again where prescriptive comes in, because this is about acting on the predictions. So you say what could happen, so how to make it happen. So you talk about analysis that suggests the prescribed action. And then cognitive is really more focused on the human-computer interface, where you start reason with purpose, you interact more naturally, you learn at scale, you're more active. So you will find that this will be incredibly impactful, but obviously need some more breakthroughs, and but you already can start deploying some of the cognitive type of analytics as well. Okay, so that was that. So I'm gonna, without further ado, I'm going to just quickly mention, I want to shift now to more the technical side and also some of the biomedical applications as well. So, and to kind of lead me into that, this is now more relevant to what some of the things that we are thinking about from a business perspective, but it also talks to pharmaceutical and healthcare stakeholders. And I think the potential here for us in Africa as well, to actually create a healthcare data analytics ecosystem for Africa, where there could be a value exchange of data, insights, applications, analytics services. So if you think about all the producers of data, you've got these hospitals and universities, and you've got all sorts of different types of companies that's doing, for instance, precision medicine for oncology, or just digitizing electronic health records, etc. With all that data, if it becomes available to, if you can start really unlocking value with that, using artificial intelligence, data science, machine learning, etc., there's great opportunity to unlock value. And if you think about this side, you see more the data management and access and governance and all of that. But on the right-hand side, you see consumers. And this is now, from a pharmaceutical perspective, you'll notice there's a number of these companies. There's hospitals mentioned here. There's medical insurers. There's equipment providers. There's medical equipment providers, etc. All consumers of data as well. So there's quite a bit of value that can be provided to those as well. So if you create a healthcare data analytics ecosystem, and if you think about analytics on this side and governance and looking after the data, you've got this kind of exchange between producers and consumers. You actually create a multi-sided platform around that, which is pretty exciting. So I would love to explore this with you guys as well. And this is maybe just talking about structured and unstructured data, different types of data that's available. So really what we're talking about here, what is a different application? So here is an example where we talk about the real-world data and the real-world evidence. In this instance, we are focused on drug discovery and development. And when you look at the left-hand side here, you will see pharma data, RCT observational. You see consumer data, social media, claims databases, test results, lab values, pathology results, hospital visits, services details, mortality, other registries, pharmacy data, electronic medical health records. Now think about all this data that's available. If you've got only pockets of this data available, you can just unlock so much value. But if it's possible to actually access all of this type of data, you can really address, you can have meaningful questions that makes the best and most of the available data. You can start doing fit-for-purpose data analytics, and you can externally get validated findings. So these are things that we talk about real-world evidence, and plenty of things that to actually drive business intelligence and business value. So I think this is kind of very important frameworks to think about how one can unlock value. And this is an example of just one of the companies that I'm also involved in and busy with. And as Cortex Logic, we are AI engine for Mosaic. Mosaic is focused on precision medicine for oncology. And if you think about this again, so you've got your doctor, hospital, patient, laboratory, and from the hospital, you can actually, if you can put your electronic health record into this private data set of real-world data. Via the laboratory, you've got genomics data and sequencing, where you do whole genome or whole exome or single-cell sequencing. You've got that data available within context of an electronic health record, for instance. Then you can start making that available. You can start unlocking value. So you can say, let's create some digital assets of real-world evidence utilizing that, and so forth. Other types of data is, for instance, organized cell cultures, and you can do test drug and drug candidates. So that is also going to this private database. So there's multiple things that can go in here, but the key thing is how do you unlock it? And this is where the opportunity lies. And one can also look at it, if you look at the left-hand side here, right at the start, I mentioned different types of data sets from different industries, for instance, where you can unlock more value. So if you think about pharma industry, wonderful opportunities and data there, identify clinical trial patients, identify candidates for treatment, so there's various things that they can do. The health insurance industry is obviously very interested in identifying possible treatments with high probability of success. So you want evidence for value-based reimbursements and all of those type of things. You want increased confidence for experimental treatments. And then if you think about the public sector, increasing confidence following public procurements of drugs, negotiating power of producers based on evidence, all of that. So there's lots of value for the different sectors if one can actually make this happen. So that is the opportunity that's out there. Okay, so I think this is there's some other things in this presentation, but I'm going to stop with this particular one. I just want to say, if you think about the Internet of Things and realizing the true value of the Internet of Things, artificial intelligence is really essential to realizing that. So I'm going to share this presentation with you as well. So the rest of this presentation is really focused on IoT, manufacturing, customer services, and showing a range of applications in that space. But I'm going to just stop the presentation at this particular point in time and just move over to the biomedical one. And here I'm not going to do the full presentation. I'm also going to make this presentation available. And so let's just put this into full screen mode. So the purpose of this one is just to shift gears. And because we are talking to pharmacists and biomedical engineers, etc., so I just wanted to highlight some of the AI applications as well. At the end, I also just want to mention something about DeepMind's AlphaFold, which is a pretty exciting development by DeepMind in London in this space. But let's just quickly go into this presentation. So I'm just going to skip some of these slides because I did refer to this in the earlier presentation. So now let's just go a little bit into what deep learning is and availability of data and stuff. And then after this, I'm going to go into biomedical engineering and some of the applications. And I'm not going to go into a lot of detail. So this part of the presentation is going to be much shorter, but it's just going to give you some interesting ideas. And if you've got questions on some of the applications that I'm going to talk about, then you're most welcome to do that afterwards or even after I've seen the presentations as well. So if you think about the deep learning recipe, okay, what made this possible? And it's really having big data available, having structured and unstructured data available. And what's really exciting for me, because I've been in the AI space, I did my Ph.D. in artificial intelligence in the 90s and started applying artificial intelligence and machine learning in many industries in the 2000s. And there was quite a bit of work on structured data. And there was a lot of value that one can unlock with structured data at that time as well. But what happened in the 2010, 11, 12 upwards, the last decade, was really the deep learning revolution, where you've got deep learning making it possible to create state-of-the-art performance or superhuman performance or performance that compares to the effectiveness of humans in terms of certain applications, but by using unstructured data. When I mean by unstructured data, it's data like video data, audio data, text data. That is examples of unstructured data. And with deep learning is really an incredible effective tool to actually provide state-of-the-art solutions on unstructured data. So suddenly we've got a toolbox that we've got already plenty of tools that deal with structured data. But now we've got a toolbox that really help us with unstructured data. And we've also made some improvements with the algorithms. We've got tremendous computing capabilities. If you think about distributed computing, in-memory processing with Spark, if you think about GPUs, if you think about TPUs that Google make available, it changes the ballgame. Suddenly, we can execute things at scale. We can work with data at scale, which makes a tremendous difference. And there's really, if you think about big data availability as a driving force, you can see this is an interesting graph that shows data being more analog, say in the 1986 and in the 80s. And the very interesting curve becoming digital, really 2008, 2010, what's also interesting here is this is also the time when you saw the deep learning revolution, effectively, and the value being unlocked. So it really is a move from analog to digital. The computing power. I just earlier on mentioned about CPUs optimized for serial tasks. You've got GPU accelerators optimized for parallel tasks, and you've got TPUs. TPUs is TensorFlow's processing units. And TensorFlow is one of the, well, it's a top deep learning framework being utilized as well. And as a matter of fact, I think Google is making that available for free for research purposes. Or at least that was advocated when they were here in South Africa, in Cape Town, at the Deep Learning Indaba. So if you think about traditional programming versus machine learning, with traditional programming, you obviously have data as input and you've got a program. You need to write a program. And you give this a computer, and you get an output. With machine learning, you've got abundant data. You give it output. So in this case, obviously, that means that you actually give it, say, the labels, say this should be the outcomes, and what it actually produces a program. So what do we mean by the program? We actually mean the model. It's actually generating the model that does the input-output mapping. And when we say input, output. So it goes from the abundant data and generates the output. And that's kind of the difference. So it's a slight paradigm shift if you think about it from that perspective. Now, if you look at machine learning basics, this is just showing actually the process you go through. So there's two phases there. There's a training phase, and then there's kind of a test or prediction where you actually just apply the model. So during the training phase, you've got label data, and you apply the machine learning algorithm, and that generates the learned model where you learn the parameters of this input-output mapping. You feed the data in and it gives you a prediction. That's effectively what machine learning is doing on a high level. But obviously you get a whole range of different types of machine learning techniques. So this is kind of showing that as well. So you see a bunch of unsupervised learning. And you see that can unlock value from looking at natural groupings in the data and patterns and so forth. Very, very powerful. You get things like autoencoders that can actually give very optimized descriptions of data, or kind of embeddings or descriptions of data as well. So almost like you create these internal representations. And this is exactly what's happening in the human brain as well. We're creating these abstract or internal representations, and it's actually going from, it's kind of on a spectrum from low abstraction to higher abstraction, effectively. Now, supervised learning is we actually give it labels, and you actually classify data. Reinforcement learning is interesting. It is where you actually give it a kind of a score. You've got and based on the score, you actually have a reward, or kind of a signal where you actually say you penalize it or you give it a reward, and you feed that back. And that's almost similar to the supervised learning, where you actually give it the label. Here, you just give it a signal in terms of it's actually on the right track or it's not on the right track. If it's on the right track, you reinforce it by obviously rewarding it. And then optimization is another category as well. So just to differentiate between supervised learning and unsupervised learning, but this is just an example of supervised learning. So what we know, what we want to know. And if you think about stock prices, for instance, you've got Monday stock price, you want to predict Tuesday stock price. That is very simple examples of supervised learning, where you transform from one data set to another. Unsupervised learning is just really, if you think about it simplistically, is just grouping your data. So you've got lots of data points, and basically what it generates a list of cluster labels. So it actually classifies your data based on the natural groupings in the data. And I don't want to go into too much detail. Obviously, as healthcare professionals, you know about neurons in the brain, but you can just see that basically with artificial neural network, you're trying to emulate in a very simplistic way what's really happening with neurons specifically. So you've got a neuron, you've got, say, various inputs or synapses or specific inputs that's coming in. You sum this, you can take it through an activation function. You do get a signal, and you can pass it on as well to other neurons. So in a very, very simplistic way, it's emulating what's really happening there. And if you think about the various techniques, this is also an interesting way of looking at it. So you can look at your supervised techniques on both sides. This is more shallow versus deep. So the moment you get to deep, you get to more convolutional neural nets, recurrent neural networks, and so forth. And the shallow the shallow techniques is more the support vector machines, perceptrons, boosting, decision trees. And then in between, you would find the more unsupervised ones that can go from shallow to deep as well. We've got autoencoders, for instance, or you've got techniques like Gradle-based functions or RBMs or deep leaf networks, etc., more probabilistic networks as well. So this is just kind of showing it's an interesting way of just looking at the various techniques that's available. So I'm just going to, there's many resources that talks about a variety of neural network structures that's available. So on the one hand, we can talk about the algorithms, but there's also, if you think about how you actually structure these kind of neural networks. So what you see on the left-hand side is just different ways of structuring these type of neural networks as well. Again, showing some of the very exciting stuff that's available. And maybe on this particular slide, what you also find is you also have different types of cells or different types of neurons, like recurrent cells or memory cells or different memory cells or convolutional or pool cells that we use in especially for image recognition and those type of applications as well. But you can see these kind of structures that we can create neural network structures utilizing the different types of neural nets, neurons that you can create, artificial neurons. Here we show a little bit more. So this is an example of some of the convolutional neural nets and so forth. I don't want to go into too much detail here. So why deep learning? I think what we find with older learning algorithms, it's actually the performance is flattening out if you provide it with more data. So what deep learning did was effectively, when you feed it with more data, it actually increases performance, which is very exciting. And it opens up tremendous doors around that. So this is actually a slide that I got from, I think, Dr. Lex Friedman. He's at MIT, and he did a recent presentation, I think this year, in January at MIT, where he just summarized the state of the art in deep learning, talking about breakthrough developments in 2017-18. And I think it's very important to make sure that you've got this in your toolbox. And it's another thing that's absolutely critical is to just think about staying in touch with the different tools that's available. What we really find here is there's almost like on a quarterly basis, there is some breakthroughs and improvements. So just to give you some examples, so BERT and natural language processing, if you're into natural language processing, that is for sure a breakthrough tool that's or library that's available for natural language processing. I would really advocate. There's also Tesla's autopilot hardware was another breakthrough that's available. If you think about AutoML is making things so much easier in terms of we just showed earlier on all those different neural network structures, and obviously along with the neural network structures, you've got lots of parameters that you need to optimize and figure out. So AutoML is actually helping you with that. And ADA.NET is actually AutoML with ensembles as well. So very exciting stuff that's actually making it, giving you more powerful tools to actually create better solutions in a very, very quick way. And there's the same also with AutoAugment. It's kind of using reinforcement learning to do data augmentation. I think you also see the creation of synthetic data. You can actually train deep neural networks with synthetic data. If you've got limited data, you can actually generate that data, make it available. But anyway, so if you go through, I think there's a presentation on YouTube that actually goes on a high level and talks to each of these things that's available. So very exciting. The other thing I wanted to quickly mention is the deep learning frameworks that's available. And what you find, and I would really recommend you start playing around and using this if you're not already doing that. But some of the top ones is TensorFlow, and Keras is actually on top of TensorFlow, so like a higher level abstraction. And also in terms of Theano, it's also on top of Theano. PyTorch from Facebook is also very, very powerful. And I know that a lot of universities are using that. But some of the factors to consider here, is the learning curve, the speed of development, the size and passion of the community. And we know that TensorFlow has got the biggest community at this point. You can see Keras is being heavily used as well because it's abstracting things and making it easier to use some of these machine learning techniques. And if you think about scikit-learn in Python, for instance, Keras is just similar to how you actually use scikit-learn. So it's really an easy way to get going with machine learning. PyTorch is also, you can see that community is also growing. But anyway, very exciting, these frameworks. It really opens doors, and it's pretty exciting. Okay, so I'm going to skip the details around deep learning and all of it. Maybe I just want to quickly show this particular one because it's kind of illustrative to what one can do with deep learning. So this is an example of we actually do, say, facial recognition, and you typically feed it the raw images. And if you take it through the layered structure as well, what it does is really in these mid layers is actually really zooming in on edges, nose. You can see it's actually putting those edges together, creating noses and eyes, and then getting to specific types of faces, etc. So this is what we talk about, this nonlinear transformations that's happening across multiple layers, and showing on a very high level how you can actually use convolutional neural networks to actually do facial recognition. So I'm just going to skip some of this, neural nets and so forth. So I just want to quickly focus on the biomedical applications as well. Very exciting developments with AI, DeepMind, and with AlphaGo and so forth. Now, next era. So I think I'm very excited about the whole application of artificial intelligence, AI, machine learning in the healthcare space. And what you will actually find, I've got this slide here that's showing the AI heat map. This was just 2017, but this has been heavily increased after this as well. But you can see the top category of all industries, if you look at this, where investment is going into, even since there was kind of a pattern since 2012. You can see it's going into healthcare and at an increased rate. You can also see fintech has picked up heavily here in 2017, but you can see healthcare is one of the hottest areas of investment as well. So, and we also look at all these players. So it's not your typical pharmaceutical players, but you also see many, many different other types of players also coming to the fore and entering the healthcare space. Now, if you look at some of the biomedical engineering applications, and this is quite exciting if you think about this and how we can create and shape a better world and better healthcare. One of the first ones is really focused on computational pathology and tumor detection, where AI can play a major role to do the, say, the tumor identification. Another one is segmentation and tracking. We can identify the areas of the tumor or any other anatomy of interest. You can look at your MRIs and pathology slides and ultrasound units, etc. Another application is around registration. We've got, say, multimodal registration images. We can use neural networks for that. Another one is touchless interaction in the operating room. So I think we see these kind of applications where AI is being utilized to actually solve pattern recognition problems of capturing motions and gestures and using them to interact with modalities in the operating room. Very interesting and exciting, that particular thing. And then you also see with guided surgery. You see plenty of examples there as well. One that we are also involved in at the moment is where we're looking at hospital benefit management and looking at the risk and how do you do exception management around this as well across the multiple different types of things that you can get there. If you think about pneumonia, for instance, or diabetes, or you think about different illnesses as well, how do you deal with that? How do you deal with exceptions, and how do you make sure that you handle it in a proper way? So that's another area of application. Other things here is drug discovery, protein folding, and alpha fold. It was the latest from DeepMind. Very, very exciting. Actually, at the end, I will just quickly go to that particular website and just quickly show you animations around this as well. This could open up so many different doors, and it shows you what is possible. And we're just doing it right now. So there's so much opportunity to unlock value around that. If you think about sequence analysis, gene finding, multiple data set integration. So there's many, many different types of applications. So just let's just have a look at a few. So if you think about radiology, pathology, and dermatology, those are definitely hot areas of biomedical applications. And if you think about one of them, say, for instance, you're looking at metastatic breast cancer. How do you detect that? So what they typically feed in here, so again, you've got your training phase and you've got your test phase. So with your training phase, you've got some sample data where you're looking at whole slide images. And you can see the training data can be divided into normal data and then tumor data. And here you can see applying a deep convolutional neural network type of model to actually predict the probability of a tumor based on that. So that's an example where you train it. Now, when you've got a trained model, you can start testing it, where you actually give it again a whole slide image, and you actually get this overlapping image patches, and it can actually provide you with a tumor probability map based on that as well. So a really good example of this. Another one is dermatology that we've talked about earlier on. So here you've got a range of different types of data that you can feed into a deep convolutional neural network. And it can actually start predicting the various types of, different types of inference classes, where you can actually predict a malignant type of lesions and the benign ones. So here in this case, 92% malignant, 8% benign, and based on different types of training classes as well. So you're looking at the skin lesion image, take it through the neural network, and it actually does that inference for you. This was done in 2017. This is exactly the same one again. So basically what you see here is there's lots of different applications where you're taking the medical image and you apply advanced machine learning, and that can lead to transformed patient care. So here's an example of prostate MRI, a company called Maxwell MRI. They're actually focused on that particular application. And here, what they're saying is an image is worth 1,000 blood tests. So with this MRI, using machine learning, you actually get a really high-level result in terms of predicting prostate cancer. Arteris, this is another example. This was the first FDA approval for clinical cloud-based deep learning in healthcare, so they are focused on that. Another company is called Lytic. They are looking at deep learning spots disease early using chest X-ray, so they're using detecting kind of diseases using that. And then Zebra Medical Vision is an example of a company that uses AI to inform cardiovascular and metabolic state of patients and predicting the risk of heart attacks and strokes, which is awesome. So you can see these kind of focus areas and people applying advanced machine learning to medical imaging and really transforming patient care, which is fantastic. Now, lots of value to unlock with healthcare, electronic healthcare records as well. And the big problem in the pharma industry, I'm going to end with this. I've got a few slides just on this and then pretty much done. And then we can have open session in terms of questions. So if you think about the pharma industry, there's a major problem. So the cost to develop new drugs is, as you would know, is greater than, say, $2.6 billion US, and it's growing. And you can see the things that's involved here. Well, it's also the length of time as well. It's 10 years, the average amount of time it takes for a new medicine to go through the entire R&D process. 12%, the percentage of drugs entering clinical trials that result in an approved medicine. And you can see this expenditure that I just referred to. That's the average cost to develop a new medicine. So the question is, how can we use smart technology? Can we use artificial intelligence? Can we use the data available to actually expedite the development of new drugs? Can we use it to actually reduce the cost? And the answer is yes, for sure. And this is just, again, showing the biopharmaceutical research and development process that typically goes through. Long, massive regulatory process as well. And what was interesting here is just what is the causes of clinical failure, and kind of showing the different aspects of it. There's commercial reasons and efficacy and operational and safety and strategy. You can see efficacy is a major part of that. And it's quite interesting because it's actually showing this across the various, you can actually see, if you look at efficacy, we just talked about efficacy, you can see 2000, now it actually, okay, this one is actually kind of, but it's still extremely high. Even hasn't really improved over time. But anyway, so one can dig into all of these kind of things. So the question is, how can we use artificial intelligence to create these big breakthroughs? And this is a quote from Thomas L. Friedman, was saying, big breakthroughs happen when what is suddenly possible meets what is desperately needed. And what is suddenly possible, I think with advanced machine learning, AI, deep learning, the amount of data being made available, we can start solving problems and creating these breakthroughs. And what we find, if this is just from news, where we talk about the various companies that's involved, you can see IBM is obviously heavily involved in healthcare and R&D and so forth, but you see many other companies really, really focused on this. And you can see also AI-powered drug discovery captures the pharma interest. So it's very recent, things are happening around this. And you can see even here, chemists pin hopes on deep learning for drug discovery, just exactly what I've just mentioned. So this is just showing, and I'm going to end with this because it shows the high-level way of looking at how applying machine learning or deep neural networks to this. You can see the chemical compounds as a source of data. You can see activity data. You can see fingerprint activity, feeding that into a deep neural network. And then on the output side, it's really about predicting the drug activity and multiple targets, active, inactive targets, etc. So if you apply a drug database, you can see identifying diseases. And here is another example of deep learning in drug discovery. You can see the different types of data sets and compounds here. Caffeine, ethanol, lithium ion. You've got labels, you've got structures, feeding that in there. And you can see, for me, the interesting thing here is just how these kind of neural network structures are being used in innovative ways to actually create new compounds and looking at predictions as well. And very, very interesting ways of utilizing deep learning. Anyway, so I think I'm going to end with this. I'm going to make this slides available. It's just, I think this is showing some other applications, toxicity prediction, and some specific models around that, which is exciting. I think this is the last slide anyway. So I think at this particular point, I'm going to end. So thank you very much for the opportunity to do the presentation. Ariola, I'm actually going to move over to you now. So, and I'm just going to quickly close this and go to my Google Hangouts and stop sharing my screen. I think you're on mute, Ariola.
Yeah, can you hear me now, sir?
Right. So I just want to quickly see
Hello, can you hear me?
Stop the screen share. Oh, we can just keep it there. It's fine. So yeah, I'm open for questions. So let me just quickly go to the Hangout. Is there any specific questions? I see there's a bunch of things here on the top chat. So I don't know, Ariola, if there's any questions from you.
So I have a question. A question myself. So you talked about the pharma industry and lots of problems we have in the pharma industry, the length of time it takes to cover a new fund, and the amounts of money that goes into it. Recently, 2 days ago, I was talking to where is the echoing? Hello, can you hear me?
Yeah, I can hear you. If you can just repeat the question, Ariola.
So I was going to ask, right? So for a country like Nigeria or just the average African country that is looking to do some work on applying AI into drug discovery, what's the starting point? Really, because you want to think about using GAN, for example, to say you have some chemical structures, right? So you pass the chemical structure network, and then some new chemical structures are developed. How do you know which one to pick? How do you go into simulating? What's the starting point of doing all of that research work?
Yeah, so what I would recommend, so by the way, let me just get my screen back on here. Oh, sorry, my camera on. Okay, can you see me?
Yeah, I can.
Okay, great. Yeah, so you talk about what's a good starting point. So what I would recommend, you are the young pharmacist in AI.
Right.
What I would recommend is really also connecting with Data Science Nigeria as well, because you would find people that's really focused on data science and the technology and how deep learning is working and so forth. And when you actually connect domain experts with some data science or people that's got some expertise in machine learning and data science, I think you can start creating some interesting solutions. And you can start with, say, quick wins, very specific, simple opportunities. So what I would recommend is, because you've got guys that's pharmacists, that's looking at very specific problems, you've got the domain expertise, and the way to look at this is to formulate what would be a quick win type of application. Identify what type of data is available to potentially address that particular problem that you want to look at. Say it's drug discovery, whatever it is. Then the next step is to actually get really, if you don't have the expertise within your community, there is to actually hook up with partners or other data scientists and deep learning specialists. You do get guys that's really proficient with, for instance, deep learning convolutional neural networks, maybe applying it to facial recognition, etc. But the same skills can be utilized to actually do image, say, microscopy image analysis and looking for different features and different things as well. And there are, what I also would recommend is, if it's an image recognition type of problem, that one actually goes through, there's lots of courses that the basic on safe image recognition. And then what you can do is to actually say, okay, how do I apply this to my type of images? And then you can obviously start training that. And there's also, I think also some of the big tech players do make quite a bit of cloud computing available as well, if you don't have your own deep learning hardware. And that is also more affordable these days. You can actually buy your own deep learning computers with GPUs and even TPUs. NVIDIA is making lots of different types of hardware available as well for deep learning purposes, which is pretty exciting as well. But anyway, so again, if you go to these 5 things that I've mentioned earlier on, you need to think about your data, you need to think about your technology. As part of technology, you think about hardware, you think about skills, you need to think about people, what kind of skills, and I think it's the marriage of domain expertise with data science capacity and data science skills and AI machine learning skills that can make a difference there. So yeah, I think there's different ways of really to get started there, but I would say get all those pieces together and really focus on quick wins, and then you can start unlocking value.
Right. One more question. You talked about machine learning and deep learning, and then I want to ask, when do you know when to use machine learning and deep learning? Deep learning should perform machine learning. We have seen projects where deep learning models were used and machine learning models were used, and then the machine learning models, for example, perform deep learning models. So what's the bottom line? How do you know what to use deep learning and when to use machine learning for your work?
I didn't get everything, but I think you were talking just to rephrase the question at a high level. So were you saying, when do you actually use machine learning? When do you use deep learning? And is that right? So when do you actually use the different types of machine learning? Is that right or not?
The question is, when do you know? How do you know when to use deep learning or machine learning?
Well, okay, so I think very, very important. You have to know. This is again where the knowledge about the toolbox is pretty important. So I'm going to give you a few examples. So if you think about image recognition problems, you can quickly research what is state of the art in terms of that. So there's various types of convolutional neural network structures that's available, and you can follow that and utilize that. But if you think about, say, temporal problems, we need to do predictions over time, then recurrent neural networks or even hierarchical attention neural nets, that's actually being favored above recurrent neural networks, for instance, to solve that particular problem. So if you want to look at the natural groupings in data, you want to obviously apply unsupervised learning. If you want to do embeddings, you want to look at autoencoders, for instance. So basically, my feedback is there needs to be kind of a high-level knowledge about the different tools in the toolbox in terms of what they can do, and also to look at the different use cases for how they're being utilized. And I think it's very important to understand you don't want to use, you want to make sure you use the right tools for the right problem as well. And the only way you start knowing more about how to use these tools is to start playing with the different ones. So I would really recommend making sure that the main categories of state-of-the-art machine learning and deep learning tools that's available, to really get a good understanding of what they can do and what is the applications for that. And then you can start doing a deep dive into that and start experimenting and see how you can start apply it. So, yeah, I don't know if it addresses your question fully. Sorry, I was trying to, I can put my AirPods on as well if it's, maybe I should do that. Just 1 sec.
So that works. I don't think there's any question. That will be all the questions I okay. So yeah.
Okay, can you still hear me?
Sir?
Can you still hear me?
Yeah, I can hear you.
Okay, great. So I've got my AirPods on, so it's much better to hear now.
So you talked about epidemiological data inference.
Yes.
There has been lots of work around that, although not in Africa. I read about a guy that's doing some work in Brazil on predicting dengue fever, right? And I think that's very important. So we after the first month so we are just in the first month. After the second month, we are going to be taking regression. We are going to be taking participants through predicting dengue fever. But really, how do we go about collecting data sets? What kind of data sets do you need to collect? How do you go about the entire data infrastructure and the architecture to make sure that you are supplying your machine learning models the correct data sets to predict real diseases? Take diabetes, for example, or some other chronic diseases that people really do not need to come down with, and then we can predict when and where they will come down with so that they can we can take them through several interventions. So how do you go about all of that?
Yeah, that's a major problem, and we're actually putting frameworks in place to try and collect more data and partnering with various players to actually make that possible. And it's difficult because you do have data in silos. It's almost the same problem that you find in a lot of companies. They've got data in silos. And if you don't start connecting the data, collecting all the relevant data, all the unstructured data and structured data that's available, then it's very difficult to start solving these kind of problems. So what we do is we do have, if you think about Mosaic, for instance, we're doing precision medicine for oncology. So we do have a lab that actually generates the data. And we're obviously going through a process where you can actually get to the samples and analyze it. There's microscopy images that's been generated. And the moment we generate those images, we can start applying machine learning on those images if we've got enough of these representative images available as well. But I've mentioned earlier on also just the importance of connecting other types of data. Say, for instance, electronic health records. You're almost missing a big part of a patient's information in history, health information, if you don't have that available. So if you do create an ecosystem, and this is what I would recommend. I think in Africa, I would love to see that we partner, or we've got all the different types of stakeholders, the producers of data, the users, all of it collaborating in a proper way. But you were just talking about collecting data. So just from a collection of data perspective, I think the producers need to collaborate and see how can we unlock value. So there needs to be connecting with hospitals, with labs, and medical insurance companies, etc., and see, is there ways of working together in getting access to data. So what's happening in our case is we are generating data ourselves with some of the companies that we are focused on, and we're trying to collaborate with some of the other healthcare stakeholders in the market, the medical schemes, the medical insurance companies, also the hospitals, and seeing how we can work together to actually unlock value. And it's a difficult thing. It's not easy because you want to make sure that you create a win-win for everybody involved. So it's got to be something like a private, public sector type of collaboration. We've got here in South Africa, for instance, you need to have government involved. You can have some of these, the Medical Research Council, maybe GEMBI health systems that's actually digitizing health records. You're working with the researchers, with their labs, and that type of collaboration is absolutely critical. And then part of that partnership is artificial intelligence, AI capability. And you need to think about also environments where you actually can store the data and do the analytics. So in our case, there's AWS, there's Microsoft. Microsoft is one of the partners as well, where we can store data in the cloud and making that available. But it's not an easy problem. But if you want to create quick wins, I think the important thing is to really focus on what you absolutely need to actually start at producing a result, a quick win as well. So for us, for instance, we can do we can actually do genome sequencing. We can do biome kind of analysis, feeding that back to customers. So we're looking at creating these thin line type of applications. Another thing that's interesting is one of the companies is called Foster in our group, and we're looking at treatment plan. You think about drugs and you're applying, you've got treatments. What happens is that people are not following through on their treatment. So there's other types of information that you can also gather using your smartphones. If you've got an app that actually captures or helps people follow through on their treatment plan, that information and data is also available. You can feed back, you can utilize that data as well. So pharmaceutical companies would be interested in how patients is actually interacting with their data. So we've got a psychotherapeutic chatbot that actually interacts with the patient, and that information and data is very valuable as well. So that's another example. But it's not easy. But yeah.
All right. Unfortunately, I've not been able to reach Professor Malanga, but I hope that as time goes on, we'll be able to reach him. We want to have him on the program so that we can go in depth into all of the biogenomics, all of the pharmacogenomics, and all of the sequencing and all of that stuff. Because
yes.
we think it's not enough to learning, it's not enough to know machine learning, take our knowledge, healthcare knowledge, and then apply it into all of these things. Dr. Ludik, I want to say thank you.
My pleasure.
I don't think we have any further questions. I told you about this sometimes last year, and then you replied in almost an hour, saying that you're going to give all of your support. I know you know that we've started the machine learning program for pharmacists. We started on the 1st of this year. and stretching on till April. We're going on to regression in February. We're going on to classification in March, and then clustering in April. And then after all of that, we'll start to look at doing Kaggle projects or partnering with Zindi.
That's
coming up with yes, African-centric problems that we can get our hands on to solve healthcare problems, basically. So thank you so much. I appreciate your effort. I appreciate your help. You're taking out your time to mentor young African families. Thank you so much. God bless you. And I look forward to seeing you later in the year. We're moving on with the AI masterclass for the pharmaceutical industry. We're getting on with it. I was with Dr. Bayo 2 days ago. We're looking forward to seeing. Yeah, I look forward to seeing you in October or thereabouts, so we can continue our collaboration. So I appreciate your kind gesture. I appreciate all of the work you've done for the AI ecosystem in Africa. You took your time to come down to Nigeria. Thank you so much, Dr. Ludik. God bless you so much. So I don't know if you have any passing words.
Yes, I do. And I just want to say, I'm also inspired by you guys as well. And what's happening in Nigeria and Ghana and Kenya and obviously in South Africa is very exciting. We need visionary leadership, people like you and this community. I know I've said that already to Bayo as well. You know, Bayo, Data Science Nigeria. Well, it's such great initiatives, and we're kind of inspirations to one another around these kind of things. And this is how we can shape a better future in Africa. And Africa is going to need visionary leadership, but we're going to need execution. So very much supportive of all your efforts. I want to wish you the best for 2019 and the whole organization, and looking forward to further engagements as well. So it was great to be in Lagos, Nigeria a few months ago. It was actually, when was it, October last year. Spent a week there at the AI. There was a deep learning boot camp. But before that, we actually had some sessions with executives and actually your industry, and also there was a financial inclusion summit, which is very exciting. I was speaking there as well. But it was great for me to just see the excitement of people that want to make a difference and embracing the smart technology. I think this is exactly what's needed. So best wishes going forward, and thank you very much.
Thank you so much, Dr. Ludik.
Thank you. Good stuff. Thank you. Bye-bye.
Yeah, take care.
Take care.